Yes, ma'am. Please start.
Okay, perfect. All right. So, okay, so to everybody who is on Zoom, as well as everyone who has tuned in on YouTube, thank you for joining. A very good evening. This, I believe, is our third live session for the course. And, the plan for today's live session is to actually discuss the first programming assignment from week 1. So the deadline was on 10th Feb. So we are now at liberty to discuss the problems from the week 1 assignment. And we will be focusing on the programming assignment because that's where we usually have the most questions from the learners of the course. But if you have any questions about the MCQ problems, feel free to ask them here or over in Discord, and we can figure things out. I think I'm not sure if it was for the week 1 MCQ set, but I think there was a clarification about, so maybe one of you remember about the n is equal to 1 case causing a misunderstanding in one of the questions. So I think, to be honest, I haven't taken a closer look at the specifics, but usually if there is a justification in more than one option, or an option different from the one that we marked as correct is being interpreted as correct, then we will typically go back and change the grading scheme. So please don't worry about that. I think it's just a matter of time. Once we get around to discussing it internally, we will have an update with for all of you. In the meantime, I'm also very happy to introduce all of you to Yash and Gaurav, who are, you know them from Discord probably already. So they are on the TA team for the course. And today's live stream will actually be guided by them. And they will be talking about the week 1 programming assignments. So I'm going to just be in the background for the rest of the stream. But again, it's the same, it's kind of the usual format. Please feel free to, this is an interactive session. That's kind of the whole point. So please feel free to post your questions or comments in the chat. Those who are on Zoom, if you'd like to discuss, don't hesitate to unmute yourselves, if you'd like to add to the discussion that is happening. So with that, have fun. And also it may be tempting to ask for hints for the week 2 assignments, but as a matter of policy, we are not discussing assignments until the deadlines have passed. But if there are, we're monitoring Discord continuously. So if there are enough requests, we might share more details in an email communication with everybody, but it would be a little bit unfair to discuss hints and things like that in these sessions that are not attended by everyone. So I hope you understand, and I hope that that's fine. So in the meantime, let's talk about the week 1 programming assignment. So Gaurav and Yash, it's all yours. Thanks so much.
Yes, thank you, ma'am. Just a query, Karthik sir, can you please make my other account also host? I will be sharing my screen through that account. Okay.
Okay, I don't think I can make you host at the moment, but we will just send a message.
So until that, I will just start discussing the questions of week 1 assignments. So as ma'am said, we have planned to discuss the 2 questions of the programming assignment week 1, which was due yesterday. So let me just go through the first question. So first question is regarding the incrementer. If you read it like, so you have a collection of n balls and each one has an integer written on it. And you also have a magic ball, which is called incrementer. And this is a magic bag. And you can, when you put a ball inside this bag, the integer written on this ball will exactly incremented by 1. And this magic bag is enough to hold any number of balls at once. So you can put any number of balls which you have inside this bag, and when you pull those balls out, those balls will have numbers incremented by 1. And now the question is, you want all of your balls to have the same number on them. And your task is to figure out what is the minimum cost of making this happen using this given magic bag. Now, if you see the constraints, first line is the number of test cases, which is 10 to the power 4. And the number of balls are from 1 to 50. And the integers written on each of the balls vary from 1 to 10 to the power 9. So let me change. Okay, I'm post now. I'll just share through my other screen.
Yeah, I think you're now co-host from both accounts.
Yes, thanks.
Cool. All right, thanks.
So, yeah, hope my screen is visible. So we are discussing this first question in which basically you are given n balls, and on each ball there is some integer written on it. Say this is a1, a2, a3, and here it is an. And you also have a magic bag. What magic bag does is, you can take some of the balls from this collection and you can put them inside this bag, and the numbers which are written in it, say this is AI, AJ, and it will be incremented by 1, say AI plus 1 and AJ plus 1 when you pull out these balls. So let's just take one example. Say if we have 3 balls, one which has numbers 1, 2, and 3 written on it. So if we put one first ball inside this magic bag, after first iteration, it will become 2. So now we have 2, 2, and 3. The configuration balls are this, is the 1 incremented to 2. Now if we put these 2 balls inside bag together, then those 2 will be incremented to 3. And now all the 3 balls will become 3, 3, and 3. And we are able to achieve same number on all balls in these 2 iterations, right? So this is like simple example. And does anyone has a doubt in understanding the question? Like everyone understood the question, right? Like what you need to what you need to do in this question, like. Okay, so do anyone want to share any intuition or approach that you had tried during your submission?
So
Yeah, Kusagra, go ahead.
yes, sir. So what I tried is I took the maximum of the number and I subtracted it from the minimum. I mean maximum minus minimum of the balls.
Yes.
So we can take it. So the minimum number of balls. The ball which has the minimum number of a minimum number on it has to be incremented at least that number of times, and the other balls can be raised with them along the way.
Yes, exactly. So I will just show what Kusagra just said. So say if we are given these integers a1, a2 up to an, and we just say we have the minimum integer all of them is a minimum, and the maximum is a maximum, right? So to make minimum number of iterations, to use the magic bag minimum times, what like intuition says is make the value of all balls equal to the maximum number, which is written on some ball, right? So we have some maximum number and we want all other values to be equal to this maximum number. And just I will take another example, say 2, 1, 3, 4. So minimum is 1, maximum is 4. So I want so the efficient way will be to make these 3 numbers equal to this maximum number, right? Because say if we choose some other number which is greater than this maximum, say 5, then it will take one extra step to increment this maximum number and also this other balls to this number, which will add up to which will add as a cost to our solution, and which won't be the efficient. The efficient solution will be to just make this all numbers similar to this maximum number. And now, the problem becomes, what is the minimum number of steps we need to perform such that all of these numbers become same as this maximum number. So if you observe that in each iteration, the number of some ball gets incremented by at max 1, right? Either you put it inside the bag or you don't put it. If you put it inside the bag, it will get incremented by 1. If you don't put it, it won't get incremented. So in each iteration, it will get incremented at max 1. So just consider the minimum element. Here the minimum element is 1. You want to make this minimum element same as this maximum element 4. So according to this condition, in each iteration, you can increment the number at max by 1. How many iterations it will take to make the minimum number equal to the maximum number? It will be max minus min, right? This is the minimum number of iterations required to make this 1 equal to 4. This minimum number equal to maximum number. So what just Kusagra said is, if we take exactly this many iterations, and in each iteration we put this minimum number ball inside the bag, so that in each iteration it will get incremented by 1, and at the end of this many iterations, the minimum element will become same as the maximum element. And what about the other elements? The other elements, because these other elements are between min and max, so we can put them in like some of the middle iterations, because since we can increment 1 to 4, we can always increment 2 to 4 by putting the second ball in the starting iterations. If when 2 becomes 4, we won't put it again inside the box. So like by this argument, you can show that the minimum number of iterations required to make all of these numbers written on the balls equal will be the max number minus the min number. So everyone got how we came to this result? Or should I repeat, or do you have any doubt in any of the statement that I told? Okay, so basically our problem statement reduced to, you are given an array A, you find the maximum element of A, you find the minimum element of A, and just subtract A max minus A min and output this number, right? Basically our problem reduced to this. And to find the maximum and minimum element, you can just traverse through array and you can keep like you can just initially take maximum as 0 and just traverse through array and update this maximum if you get some higher number inside there. It will just take order n time, right? So you have this 2 3.
और first term और last वाला select कर सकते हो.
Yeah, you can sort the array, but if you observe like what is the time complexity of the sorting algorithm, it's for merge. If you take merge sort, it will be n log n, right? But we don't want all the elements to be sorted. We just want the minimum and maximum element, and that we can achieve just through traversing through the array in order and time. So it will be more efficient than sorting, right? Why we are not using why sorting is not efficient? Because we only want the minimum and maximum element. If you want all the elements in sorted order, then we could have used sort. But since we don't want that, we can just traverse through the array in order and time and just fetch out the minimum and maximum element, right? That will be more efficient than sorting, right? So like this is a basic outline of the algorithm that we need to do, and I will just now show coding it up and running the test case so that you will understand. So just like ignore the starting code. I have just written it in order to handle the input and output in this text files instead of the console. You can always take input from console and get output to console. So the first input which we are given is the test case. Let's say t equals to input. T is the number of test cases, and for each test case, what are the inputs? First input is the n, which are the number of balls, and the second input is an array. Like they separated integers which denotes the numbers written on the ball. So I'll just store it as an array. So I have taken the inputs. Now I want the maximum element. So Python has this inbuilt function max, which fetch out this max element from an array. And Python also has a mean. It also has a mean function, which is just a mean, and it will take argument array, and it will give the minimum element out of this arrays. And what will be the answer? It's just max minus min. So I've taken this first test case. If I just run it, so this is the output. Like if all balls have same numbers, then we don't need to increment any of the numbers because all of them are already same. So the number of increments will be the number of which times we will need to use magic bag will be 0. The second input is 1000, 1000, 1000, and 1001. So if we put these 3 balls inside the bag once, then all of those 3 will become 1001, and we'll get all the 4 balls as equal numbers. So that we will need only one iteration. The third is 12 and 10. Here also this ball having 10 number, we'll put it 2 times in the bags. So it will become 12 and both of them will equal. So answer will be 2. So this is the simplest code that you can write in Python for this problem. So does anyone have a doubt in this code or anything related to this question? Okay, so nice. So I think we can start going through the second question. Yes, we'll take over to the second question.
Okay, thank you, Gaurav. So hi everyone, I am Yash, and I will discuss the second question now. Let me just share my screen. Can someone confirm, is my screen visible?
Yes.
Yeah, thank you. So okay, so in this question we are given 2 integers n and m, and what we have to do is we have to write m as a sum of n numbers such that the GCD of these numbers is maximum. So I guess all of you are clear with the question. Okay, so just wait a minute, I will share my screen. Okay, thanks. Okay. So okay, I guess my I guess the tab screen is visible. So basically what we have to do, we are given n, we have to write m as sum of n integers such that the GCD of these integers is maximum. So I guess the question is clear to everyone. Okay. So does anyone want to share their approach? Okay, all prime factors. Okay, but okay, you said you can go with all prime factors of n. But what if I give you something like what if the GCD need not be a prime number?
Sure.
Yeah. Yes, Kushagra.
So what did I tried is that, let's say we have a greatest common divisor of this array as b. So
Okay.
every number will be divisible by b.
Okay.
So that means that the total number that we have, that m, will be divisible by b.
Perfect.
Yes, sir. So what I tried is I I tried to go down the array. I mean, go down the values of m in the range m to 0, m to 1. Sorry. So, but anywhere where I can find that we can get exactly the number of values. That means at the point where we can take the n values from m, where sorry, that means I tried that. Let's say I sorry, I'm weak in explaining. But what I mean to say is that we take the value as m by n. N will be m by n. Okay, because yeah, m by n.
Yeah, you mean
Yes, sir.
slash as in m by n is integer. Yeah.
Yes, we can't have a greatest common divisor greater than this, right? Because we can't get then n numbers from it.
Okay. Yeah.
So
Right.
so I just went from the range m by n to 1, and I just checked which number is divisible by m. If I found which number is divisible, then it would be the greatest common divisor of the whole array.
Okay. But okay, so you are correct. So, but there is one. There is one thing. So when you go from m by n to 1, so the value the value of m by n can be how much the value of m by n can be. It can be 10 raised to 9, right, at max.
Yes, sir.
Yeah, and I think the time limit for a question is 1 second. And if you know the thumb rule of computative programming, that in 1 second you can perform 10 raised to 8 operations. So if you like go from m by n to 1, so if you go from m by n to 1, so it will take only, it will like so if you're performing 10 raised to 9 iterations of your for loop, then there is a possibility that your code will be not accepted by the, you will get a time limit exceeded error. So I mean the test cases for this question was not that tight, but yeah, I can certainly frame the questions in frame the test case such that you get a tight bound. Did you pass all the test cases?
Yes, I passed on all of them.
Yeah. So I could give a very tight constraint on your question, and yeah. So I will. Okay, so but you are correct. So what I will what Kushagra said and what someone else in the chat also mentioned. So we know that A1, A2 all up to AN will be divisible by some optimal GCD, that is B. Correct. So this implies that M is also divisible by B. Correct. So what we can do is So since m is divisible by b, so our answer is actually a factor of a divisor of m, but that number cannot be greater than m by n, or rather you can say cannot be greater than floor of m by n. So everyone agrees with this?
Yes, sir.
Yeah. So we just have to find. We just have to find the find that divisor of m, which is just smaller than m by n, and just smaller than m by n. That's it. So I will share my screen to how I have written the code. Okay. So I'll just present my Visual Studio Code. By the time is let me check YouTube if there are any. Okay, there are no doubts over here. Okay, I will just share my screen. So is my Visual Studio screen visible?
Yes.
Okay. Yeah. Also, no need to call me sir. You can call me yes. So okay. So let's go to the question. So so let us look at the input format. So we are receiving just two integers n comma m. So we can write. We are taking input because they are n comma m are spaced integers. I will. So I took n comma m as my n comma m as my input. Now what I need to do. So the thing with we have to find a divisor of m. We have to find a divisor of m as just smaller than m by n. So, but if we check by brute force all the divisors of n, it won't be possible. So what we can do, we can in order to check every divisor of m, we can check up to root of m. So does anyone know the logic of why we need to check till root of n to find all the divisor of m? Yeah, it's not like they will repeat after that, Ritik, but it's like if I is a divisor of m, which is less than root n, then there should be a corresponding divisor which will be greater than root n, so that I into m by I is m. So the maximum value of that I could be up to root n. So it's like so it's so if you write a big if you write a number and write all the divisors of this number, you will realize that the first and last that for every divisor you will have a complementary divisor. So usually all the numbers have even numbers of divisors except for square numbers. So yeah, so basically you just have to check till root n. So I will write a code. Okay. So what I've written here is I will check for divisors from 2 because I know that one will always be a divisor. So I will run from 2 to root of m, and this plus 5 is just for I am writing this plus 5 just for safety because it sometimes happens that int of like this number may not be a proper integer, and this int function will actually behave as a floor function. So I might just for safety, I am using this plus 5. So just so that this number is definitely greater than root n. So what will I do? So if m is divisible by I will also declare a temporary variable answer which will store my answer. You know that one will always be my answer. So if m mod I is equal to 0, if m is divisible by, what I can do, if my I is just less than equal to m/n. So what we can do, our answer is equal. So our answer becomes a potential answer. Edit answer as max of answer comma I, because we need the greatest divisor which is just smaller than this. And second thing I will do, if m by I is less than m by I is less than m by n, I will write answer is equal to max of so what I did, if you know, I will just open over here. So suppose I take the number 12. The divisors of 12 are 1, 2, 3, 4, 6, and 12. So what I'm checking the divisors of this up to root of 12, which will come somewhere over here, just between 3 and 4. So what I'm actually doing is I will check. I know that 1 will always be the divisor. I will check for 2, and when I'm checking for 2, the case for 6 will automatically be tested. So basically, I'm going through all the divisors in root and time to check whether. Yeah. Okay. So to check whether whether that is a potential answer. And after this is done, so this is basically our code, and I will print the answer. Okay. So do you think this code is correct? Or is there any flaw in the code? Or if you want me to explain this code again, I can explain it as well. Yeah, so what do you want me to explain line 15 again? Okay. So what I'm doing over here is, see, here I'm checking in line 12, I'm checking whether our I is divisible, whether our IM is divisible by I. Okay. Yeah, okay. So, okay, so, but do you still think my code is correct? Yeah, you are correct, Nur Sultan, that there should be less than equal to sign. But is my code still correct? Okay. Anyone else? Do you see any mistake in this code? Okay, so you might not see, there's one mistake in the code, which you might not see right now, but if I will, let me run some sample input. So one is 3,14. So and when I run this code, so okay, why is it not? Sorry, I didn't save it. So when I run 3,14, I got 2. So for sample out input 1, it is working. So I will try for some other sample input as well. So other is 10,123. And I guess even for this, it should work. Oh, sorry. Even for this, it worked, that the answer is 3. And let me, and I guess even for this one, it will work. So even for all the sample test case, this work. But there's one small mistake there is in the code, which I guess I don't think anybody has spotted. Is there anyone who found a small mistake in this code? I'll give you 1 minute to think about it. If you cannot, then I will explain you what one small mistake I did over here. This was the mistake I actually did when I myself tried to solve the code for the first time, and then I realized this could be a great example of showing how edge cases work in competitive programming. Okay, so I will tell you.
So,
Yes.
so what if the M? I mean, what if the answer is same as M? Because we didn't check for one.
What? Come again?
I said we didn't check for one. We said that the answer would be one only.
Something.
So what if the yeah?
What? Tell me, what should I do?
So I mean that let's say that there are sorry yeah when both the values are equal, let's say n when n is equals to m.
Okay. Are these
Yeah.
equal? 3, 4, 5. Okay. So by rule, the answer should be 1, right?
Yes, sir.
Okay. So if I run this, answer is 1. That's fine.
So I think I'm mistaking somewhere.
Okay. Okay. So I will tell you what's my mistake. So this is my mistake. So if I give something like 1 comma something, and if I run this code, okay. Let me just run the code again. So if I'm given a number this big, so if I'm given this test case, the answer should be 10 raised to 9, but I'm getting half of that. That is because
This I was this I was saying that we didn't check for one, so the corresponding vector corresponding value should be corresponding
you didn't check for. We are checking for so over here. So I am checking for these numbers. I am not checking for 1 and n. So therefore my code messed up this edge case. So that's one thing you should always keep in mind, that you should always to catch out these test cases is too tricky, so you should keep an eye for it. This is one of the important thing that will be you should so this is one of the important thing you should see in competitive programming. So even in my competitive programming experience, I came across a lot of these edge cases, and these are usually around very simple cases, like the value of n could be 0 or something like that, and just very edge cases are literally the edge cases in the constraint. So like I took n1 and m as 10 raised to 9. So these are literally the quote unquote edge cases. So yeah. And second thing, so in order to fix this, I just had to change this 2 to 1. And I guess my answer will be not this one. So I am getting the correct answer because now I'm checking from 1. So I guess this is clear. And can anyone tell me the complexity of this this implementation?
Will it be root m? Because we are going to m only.
Root m.
Root m.
Yeah, perfect. It's root m only because we are taking this, iterating this root m times. Perfect. Yeah. So square root m, yeah, correct. So yeah, so this was question number 2. Do you does anyone have any doubt regarding this? I guess this is fairly clear, but if you want me to explain something again, or some particular subsection you want me to explain, I can explain.
So
Yes.
Sir, one more approach, I mean, a little change. What we can do
Okay.
is we can go from root m, we can go from root m to 1. So in this
Yeah,
case, we
yeah,
don't have to check. Yeah.
yeah. Okay, you
First,
mean I don't have to update these answers over and over again. I can like just straight away the first.
yes, sir. The first value that we get will be the answer.
Okay. Wait. It's not the first value that we get. Okay. So you are telling. So just I will take this
Sorry,
example.
I meant from m by n to root m,
Okay.
because yeah.
Yeah. You mentioned. So you told that m by n to root n. So the value of m by n can be this thing, na. The value of m by n. So if you are going from m by n to 1, so your and the maximum value of m by n could be 10 to 9.
Okay, sir, I got it. I missed a flaw. I just thought about it.
Yeah, so so basically just remember the thumb rule. Whatever you do, the multiplication of your complexity thing should never exceed 10 to 8 at extreme conditions. That's the thumb rule of competitive programming. So yeah, anyone else have any doubts? So I don't think anyone have any doubts. So I'll just stop sharing my screen. So there are will Java be available for week 3 programming assignment 1? I guess uh, ma'am would be able to answer. Yes, I guess there are some doubts on YouTube live stream. Yeah, go ahead. On YouTube, Amandeep is asking whether I can have email for contact. You can contact me on Discord. And there is someone asking, how can I get a link for this seminar? So actually, this is from this is an NPTEL course on getting started with competitive programming. Oh, okay. So you can follow those. And okay, there aren't any doubts. So I guess yeah, correct, Abhishek, the complexity is a square root of m. Okay, so I guess we are done over here.
Yeah, hi. So good evening.
Yeah, hi, Amandi.
Yeah, so can we have your sir ID or contact?
So are you on the Discord server of this course?
Not yet, sir. Not yet.
Yeah, so I will just share the a link to Discord. Okay, drop the invitation to Discord in the chat.
Oh, all right. Thank you.
Will we be discussing the answers of week 2 in the next live interaction?
Yeah. You mean the programming assignment?
Yeah.
Yeah, we will discuss the programming assignments in the next week.
Okay, thank you.
Okay, yeah.
Hi, sorry, I think I had some connectivity issues there. Can you hear me now?
Yes.
Yes, ma'am.
Okay. All right. Yeah. Sorry. I was just checking in. So you, right. So I guess, were there any, so since I had to reconnect, I have lost the chat history also. But apart from the programming assignments, were there any other questions about anything from the MCQs or anything like that that remains to be addressed?
There was like one question that will Java be available for week 3 programming assignment 1?
Okay, yes. So I think the Java solution has not been uploaded yet. I think we are working towards making that available. I mean, it has been uploaded, but there was a sort of a technical glitch with that sample solution, which we are just looking to sort out. So I hope that it'll be available in a day or two at the most. Yeah. Maybe discuss problem 7 and 8 from quiz 1, which is from the MCQ problem set. Yeah, if it's from the week 1 program, week 1 assignment, that should be fine. But I don't remember what those questions were. So could you reproduce the questions for us, Anwar?
Ma'am, actually those questions were framed by Nipun.
Sorry, but what was was it the one that was sort of discussed on Discord about the n equals 1 case. I thought that was like the first question or something. Yeah, to be honest, I don't quite remember what question 7 and 8 was. So if I see. Okay. Cool. I see. Returning the biggest possible array such that each element in the array is a factor of the two other given arrays. Okay. Yeah, I think I vaguely remember this one to be a straightforward. I think it's straightforward brute force. I mean, in terms of I think a direct combination of the two arrays, but I think the other thing we had to do.
Ma'am.
A little.
Ma'am, am I audible? Yes, ma'am. I'm confused in the question 2 of the week 1 assignment. So there is one case in which if the value is 1, then the uh, loop can stop, and we are not discussed about that in the answer because we are not given any constraints that
Yeah,
the
yeah. Actually,
values of n will be.
we haven't mentioned the domain of n, right? Like we meant it to be n greater than equals to 2 as it was discussed in the class, but since we haven't mentioned, we will typically we'll consider the answers that can also be correct if n equals to 1. So.
Oh yeah, I think about that question, as I mentioned at the start of the stream,
Yeah.
I think we will modify the grading scheme to account for both possible interpretations. I think that should be fine. Yeah,
Yes.
thanks.
Okay, thank you, ma'am.
Yeah, cool. All right. Okay, then. So I guess, yeah, so now that we are done with the discussion of the programming assignments, which was the main agenda, and there are probably no more pending questions in the chat except for so Anwar, I think we will connect back on Discord to pick up questions 7 and 8. So thanks, Gaurav and Yash, for for making the presentations today, and thank you to everybody who joined. Appreciate your coming in, and we hope to see you back next week when I think we will be able to discuss the week 2 programming assignments and any other questions that you might have by then. So thanks everybody, and goodbye for now. We'll close this session here, and we can also stop the live stream.